Sir, we are live now. Please start.
Okay, thank you. Good evening, everyone, and good morning and good afternoon to those of you who are joining from other time zones. Hope you're all doing safe in this tough period, and let's get this session started, right? So let me introduce myself briefly, and then we can get into the session, and then we'll talk about more up more on the topic, right? So to introduce myself, this is Shiva here, Siva Prasad Bommisetty, and I am a program director in IBM India Software Labs. I'm in the industry, software industry, since last 24 years, and graduated from Andhra University, and then later did a management program from IIM-Bangalore. And I'm into this supply chain related IT field since last 14 years or so, right? Brief intro about the session. So till few years back, right? Whenever we call it as an order, right? It used to be associated with a B2B scenario, right? When I say B2B scenario, between two businesses, right? And one business used to order something, and other business unit used to fulfill that something, right? But with the advent of internet, the term order has now it's become so popular, and even my 14-year-old kid now can place an order internet and then expect it to be delivered, right? So in this scenario where there are millions of orders are being placed on the internet and between B2B systems, what do we really mean by a perfect order, right? Whenever we call something as perfect, I'm sure it is associated with a lot of challenges, right? So we'll talk about what is a perfect order is, and obviously the challenges in making sure a order is a perfect order, and also we'll touch upon some of the IT systems which are trying to address this these challenges to make the orders more perfect, right? And we will also talk about how some of the modern day technologies that are in play here are helping these IT systems. And in the end, we will also talk about what are the various IT roles that we have in the area of supply chain and IT related supply chain fields, right? So with that, let's get into defining what a perfect order is, right? So while this question inspires many different answers, the foundation for the perfect order doesn't change all that much between companies, right? So when you talk about any supply chain, there are mainly two entities: a supplier who is supplying the goods, a manufacturer who is basically producing the goods, and in the e-commerce, there may be an end customer who is maybe receiving the goods, right? And when we talk about a supplier and manufacturing point of view, a perfect order is something that either a product, the right product, or service being delivered to, right? So order does not always mean a product being delivered. Order sometimes also means a service being delivered, right? Take a small example of you ordered a washing machine, and the product that gets delivered is the product, right? Washing machine itself, right? And the installation that comes along with that can be called as a service, right? And you have to place an order for service also, right? So the right product or right service being delivered to and to the right customer, right? A customer A is placing an order, you cannot deliver an order to customer B. Right place, just because an apartment number matches, it cannot go into a different apartment and a complex. So it has to be delivered in the right place and at the right time, which basically means 100% on-time delivery, right? You promised order at a certain date and certain time, you should be able to deliver that, right? And in the right quantity, right? Let us say I ordered 4 chocolate boxes, and when I really open the package, I see only 2. That's not a perfect order, right? It should be 100% right quantity. And of course, the most important thing is right condition and right packaging, right? So this talks about the quality aspect of it, right? So something gets delivered, and if it's damaged, obviously it's not called a perfect order, right? So now you can look at these conditions, right? And to make sure every order is perfect, you can imagine how much processing has to happen in the background to really make sure that such orders, more and more orders, are getting perfect orders, right? So the way that I'm looking at taking this session is basically we will talk about challenges that are affecting the perfect order, and maybe for each challenge we'll discuss what are the real life problem statements that we have, and then we will also talk about a wish statement. Okay, what if I can get all this perfect thing, right? And also we look at some of the aspects of IT systems that are really trying to make that wish true, and we'll also look at some of the technologies that are helping that, right? So I think once we look at one of the challenge, how I'm trying to place the flow here, right? So when things are looking perfect, and there are a lot of companies claiming that, hey, we are able to meet different supply chain challenges and all. There comes this pandemic, right? So we are got hit by COVID really hard, and you can see some of the examples here, right? So there are pharma companies who have medicines, but they don't know where to supply, right? They don't know where the demand really exists, which hospital, where, right? And manufacturers increased medical supplies on things like gloves and oximeters and all that, but they can they really quickly onboard their customers, right? Unless you have the customer is in showing up in your system, you will not be able to take an order and fulfill that order. And few countries even shut down, and some of the times we have seen that the raw materials are coming from suppliers from a specific country, but when a country itself is shut down, suddenly the supply chain balance got disrupted, right? And nobody knows how do I get an alternate or backup supplier, right? Vaccine production ramped up later point of the time, but the distribution challenges. Some of the vaccines have to be delivered at a specific temperature, and have to reach the hospitals and all. How do we do that, right? And a lot of governments, ministers and prime ministers and all, and various countries really want to help, but they are increasingly finding it difficult. And how do we help, right? Where does the help reach, right? So this COVID has completely disrupted what we can call as supply chains, which are getting smarter and getting better, right? And while we may not be able to address all these possible supply chain challenges in this short session, we plan to touch upon a notable few. We'll touch upon challenges like multiple channels, systems that are siloed, demand prediction, fulfillment challenges, traceability, and trust. We'll try to touch upon some of these challenges and delve deeper into these kind of things, right? So when you say multiple channels, what a channel really means is the number of ways you can place an order, right? These days you can place an orders using mobile, call center. You can even place an order on a WhatsApp these days, and on the internet, and so we'll talk about what challenges can come in each of these um, different aspects, right? So let's look at the first challenge here, which we can say that multi-channel order management, right? So what is the end goal here? Once the orders are captured, they have to be orchestrated through an intelligent order fulfillment system, right? To ensure that its life cycle is effectively managed, right? So there are some heavy loaded terms here, but we'll try to make it simplified, right? As I just explained, the channels are nothing but different ways an order can be captured into the system, and then we look at how an intelligent order fulfillment systems can really help here. So let's get into some of the examples, right? So does this sound familiar to you? So we'll talk about some of the statements, right? Customer places an order through his mobile phone, and item is not received on time. He or she calls the call center, and the call center agent could not see the proper status. He says that, sir, I'm not able to see the proper status. Let me find out and call back, right? Then after a few days, item actually received, but you found that item size that you ordered, maybe a t-shirt, it's not of a proper size, right? And since that app is from a branded store, and you know that the same store is available in the neighborhood mall, you thought you can really go there and ask for an exchange there because the size is not proper. But the store does not have any information about this in order and unable to process the exchange. They may say that, sir, the mobile order system is different and our store order system is different. We'll not be able to help you here. You can raise a request through mobile itself, right? So I'm sure some of you are able to relate to such conditions here. And what if he or she is able to place an order through a mobile, track the delivery through any means, online, website, call center, and when really not satisfied with that color or fit or size or anything, can simply be able to walk into a neighborhood store of the same brand and exchange it without any trouble, right? This is a wish statement, right? So yes, it is possible, right? So remember we talked about channels. So you can see in the diagram, these are all the channels that we are talking about, right? And an effective order management system should have these capabilities, right? So what are the capabilities? So a few things we talked about here. Accurate, available to promise data, right? So what does it mean? Customer should know right availability while placing an order, right? And if it says that it's available and it's allowing you to buy that, the moment he clicks buy it, it should get reserved to that customer, right? That's what we call it as available to promise. Flexible fulfillment options, right? So what does it mean, right? I should be able to place an order online, but request it to be delivered home, or I can place an order online. I can also request it to be picked up in a nearby store. I can buy online. At the same time, I should be able to request an exchange from a store. So these are all flexible fulfillment options that we call about, right? Visibility of order, right? Irrespective of the channel that an order is placed, both customer as well as the retailer should be able to view the exact status of the order from the same source of truth, same source of the information, right? So that's when we can call it as an intelligent, effective order management system, right? Replenishment of orders, right? What does it mean? Capability for the system to automatically place orders to suppliers when the stock levels reach a particular threshold, right? So we are again talking about a B2B scenario here between two businesses. And if the order management system is intelligent, let us say there are 1,000 mobile phones that are in the stock, right? Stock or inventory, I keep reusing these words interchangeably. Whenever I say inventory or stock, it means the same, right? So let us say, I have in my stock 1,000 mobile phones, and that mobile phone is a fast moving thing. There is a sale happening. And the moment that my stock comes to 900, and if I keep 100 as a threshold, the system should be able to automatically place an order to the supplier saying that, hey, I'm reaching the threshold, please send me more, right? And if the order management system is intelligent, it should be able to do that as well, right? And efficient returns management, right? This is even more important in these current days where the returns are like number of returns are really more, especially if it's a merchandise and clothing and all that, right? So how easy it is in the system, the ability to restock it when something is returned and make it available for future orders in really quick time, right? So these are some of the attributes that we can expect in an IT system which is capable of managing these multi-channel orders in an efficient manner, right? And what are the technologies that are supporting or in building these effective order management systems? So obviously there are programming languages. You can call it as Java, anything like that, right? UI frameworks, because there's a lot of UI where the order capturing system is there and the order management system is there. Databases, because it should be capable of serving multiple channels and it should come from the same database and all, right? And mobile app development, that's another technology, because every store nowadays aspire to have a mobile, because more and more everyone is mobile, right? Chatbots, so this is where you can even chat with a system, and if the system is intelligent, it should be able to even address your questions without a human intervention, right? And in the modern day systems, even the cloud technologies and microservices, right? The systems that are able to scale horizontally or vertically whenever there is a more demand, right? So for example, I have a 5-server system, one for UI, one for database and all that. And suddenly, I'm starting a sale. I want to add 5 more clusters or 5 more servers to the same cluster. It should be able to do that, easily and effectively. And cloud technologies are helping that elasticity and expansion on demand, right? So let's get into the next challenge that we are we are observing in supply chains, right? That is systems that are siloed, right? So the real challenge here is, in the supply chain systems, both within the enterprise as well as outside the enterprise, right? Within the enterprise means within your company, the system should be able to talk to each other system very well. And even outside of the enterprise, which means that from my company, if I'm running a company, my company should be able to talk to other companies in a language that is meaningful to everyone seamlessly, right? To work together seamlessly and provide end-to-end visibility. This, when we are able to accomplish this, the orders will move much faster, right? So let's look at some of the examples again here, right? Does it sound familiar for you, right? Before we get into this challenge, let me briefly tell you about a concept called advanced shipment notice, right? Advanced shipment notice is a very important concept in the supply chain. And what it really means, the meaning is there in the word itself, right? When a manufacturer, let us say, there is this Maruti cars, we can call it as a manufacturer, and you can imagine, how many parts required to manufacture a car. There may be like 5,000 parts that are required, right? So how does Maruti gets those parts? Obviously, they will have suppliers, right? So Maruti places an order for some parts, and suppliers fulfills that order. That means that they'll send all those parts in a truck, and it reaches the Maruti plant, and the plant should be able to verify those parts against the order that they placed, and they can let the truck allow inside, right? So when all this is happening, when a truck really comes at the gate of the manufacturer with comments, but if it happens like neither the main gate nor the manufacturer system have info on what has arrived, right? Suddenly a truck comes and says that, hey, sir, this is your order, please take it, right? And this information is not there in my system, which means that shipment notice or shipment information never received in advance from supplier. This is what the concept called advanced shipment notice. Ideally, shipment information should come into my system much ahead before the truck has come, right? So if that doesn't happen, then truck has to wait till the shipment information is received, and the receiving gate has a reference to check the materials against. Only then the truck can be allowed inside, right? So this is what sometimes we see happening if the systems are not smart enough, not fast enough, right? So what is our wish statement here, right? What if the shipment notice is received in advance in an electronic way, not as a paper and somebody takes it and inputs it. If it receives in an electronic way, directly from supplier's system to manufacturer's system, much before the truck even left the supplier warehouse, right? That's a wish list, right? So is it possible? Yes, the present day IT systems can make it possible, right? If you notice the diagram here very briefly, the top part of the diagram here is what we can call as a traditional data exchange. In the bottom one, we can call it as electronic data exchange, right? So what does the top diagram says here? So there is a customer's internal system, there is a supplier internal system, right? So let us say there is a customer, which is in this case, maybe Maruti as a manufacturer. He creates an order in his system. Then he sends that order. Let us say, that order is an Excel sheet or maybe a PDF document or anything. Supplier receives that order and he has to key in that order into their own system. Then he creates an invoice. Invoice is nothing but bill, right? Once he's supplying it. Then he sends that invoice and it may be in their own format. And customer receives that invoice and he has to enter it in their system. Only then the payment can happen. So imagine if this is happening in a manual way, how much time it can take and how much dependency it is there on the people who are receiving it, who are entering it, and what if they can make mistakes, what will happen, right? On the other way, if you look at electronic data interchange, if you look at the bottom picture, right, and customer system, supplier system, there is a EDI document, or EDI stands for electronic data interchange, and the systems are seamlessly talking to each other. They can understand what format customer is sending, and to supplier, and the supplier can understand what format that customer wants, and they can keep exchanging the documents, and directly the systems keep getting updated automatically. Imagine how fast it can happen, right? So what should what are the attributes that we expect in an effective electronic data interchange system? So one, any to any data transformation, because documents be in various formats. Sometimes the documents can be in XML format, sometimes document can be iDocs if it is SAP, sometimes document can be in positional files, PDFs, it can be anything, right? So your effective electronic data interchange system should be able to understand any type of document and should be able to convert into your own format and accept it, right? Similarly, it should be able to send it, and the other side, it should be able to understand the format, right? Second is connectivity, right? Any to any connectivity, right? I might be able to receive documents only through certain means. I might be able to receive only as emails, or I might be able to receive only through FTP, that is file transfer protocol, or I might be able to receive only through HTTP, that is a web service. So your system should be able to adapt to any connectivity option, right? Tracking and alerting, which is even more important when the documents are actually leaving your four walls of your servers and going to the other side and coming back from the other side. End to end, you should be able to track the documents, right? And reliability and scalability, right? It cannot happen like I send a document electronic way and other side system is down, right? These kind of systems are expected to be reliable and highly available, at the same time highly scalable, right? They should be able to be available 99.99% and above, right? Otherwise you may lose the orders, right? And ease of onboarding, right? We talked about onboarding as a challenge in the when we are talking about the COVID challenge and all, right? How fast you can onboard a new trading partner onto your system and able to do business with them electronically. That is also very much important, and an effective EDI system should be able to make it very easier and very effective, right? So what are the technologies here that are supporting this electronic data interchange? One, there are EDI standards. So there are standards by different standard bodies, ANSI, EDIFACT, PEPAL. So these are the standards which are defined by different standard bodies. ANSI is by X12 from the mostly in the US market. EDIFACT standard is electronic data standard in the Europe. PEPAL is pan-European language for mostly used for government entities and e-invoicing, electronic invoices. APIs that are for interface developments. Communication protocols, we talked about secure file transfer protocols, hypertext transmission protocols, HTTP, AS2, these are all internet-based transmission protocols. And messaging queues. Some of you are aware of MQ concept. There could be WebSphere MQ, JMS MQ, and there are multiple messaging queues. So these are all the technologies which will make the data exchange seamless and much faster. Okay. Let's get into the next challenge, which is demand prediction, right? So what does it mean, right? Demand prediction, your ability to analyze both internal as well as external data, right? You have a lot of internal data that how much stock is there, and what kind of orders are coming, and where do I supply and all that. And external data could be how the business climate is, and how is the weather situation, how is the transport situation. So if your systems are able to analyze both internal and external data and predict the demand, right, and also strike a right balance between sufficient inventory levels and customer demand, right? So when I say inventory, I said stock, right? So you should not be overstocking or you should not be understocking, right? If you overstock and if it is not getting sold, it gets waste. If you understock, if there is demand is more, then you will not be able to fulfill and the loss of revenue, right? So the inventory level and customer demand go hand in hand. And the better you predict the demand, the better you can strike a balance between the inventory and customer demand, right? So let's look at some of the real life examples, right? So rainy season has started, and you went to a nearby store to buy an umbrella, and he says that sorry sir, umbrella is out of stock, and then it comes next week. So what do you think about that shop? Oh, he doesn't even have umbrellas and it's raining, right? It's not that he don't want to have, but he didn't predict, or he didn't predict in the right time to get the right stock, right? You go to a clothes store, and you really liked something, and the color and everything liked, but you're looking for the right size and right color, and it's not available, and and then you ask the storekeeper saying that, hey, when can I get that size? And he says that no idea, right? That means that he has no idea what size sells most and how much he should keep it. Sometimes you may see that all odd sizes remaining and all popular sizes go out of stock, right? So the other thing, right? If you talk about services, right? So you got a dishwasher delivered, but installation took a lot of time due to technician availability. We faced this during COVID times, right? Because the product, somebody is able to predict the demand, but they're not able to predict the demand for, do we have enough technician to even install it, right? So a lot of people got it, then they kept on waiting for either technician or kept on waiting for washing powder and all those things. Okay, so that's a mismatch between two products that has to go together, right? And you are at a shoe store, and you are a shoe store owner, right? Now let us switch the role, right? So you are a shoe store owner, and there is one particular shoe model selling fast and out of stock, whereas so many other models have excess stock. Again, it can happen to any showroom person. If they are not able to predict what is a fast moving model, this can happen, right? So what is our wish list here? What if the analytical and prediction systems are smart enough to understand the parameters like type of goods, market condition, seasonal patterns, which are very important, consumer behavior, the models keeps changing and other things, we should understand the behavior, and can aid with smart suggestions for inventory managers, right? This is a wish list, right? So is it possible? Answer is yes, right? So if you look at the diagram, this is a cyclical diagram, right? So the system should be able to identify probable list of drivers for a demand and perform desired analytical transformations and develop statistical models to quantify the demand drivers, and then understand all the demand drivers using the mathematical equations, and then help the planners to make sure that the right level of inventory is managed, right? So if you look at effective demand forecasting system, it is something that it should be able to achieve some of these things, right? First and foremost important thing for a demand prediction system is that system should be able to keep learning, right? What does we mean? It should be able to improve accuracy over time, right? First time you are doing demand prediction, it may not be accurate, but over a period of time, maybe after 4 seasons, after 5 seasons, it should start giving you better and better results, right? Second is most important thing is scenario modeling, right? So you should be able to, system should be able to process huge amounts of data that you have and enable scenario-driven data decision making, right? So what it means is that, in other words, we can call it as what-if analysis, right? Oh, this is what my demand prediction is. What if the rainy season starts earlier? What if customer maturity changes? What if there's a competitor releases product, right? So your system should help you to do those what if analysis, right? And end of the day, the goal is to improve the planner productivity, right? So inventory planners typically have these all analytical models and skills, and the system should help by providing more insights to them so that they can make better decisions, right? And other important attribute of such a system is reducing the wastage, right? So if you can plan the inventory and stock better and control the production accordingly, you will not overproduce something or you will not underproduce something, right? Especially wastage is when you overproduce something, correct? And end of the day, where this all lead to is increased customer satisfaction, right? So which means that it should help reduce your stock out situations, right? So, if you go to if you know about a shop, right, where you know that always something will be available, if you have that confidence, you keep going to that shop again and again, correct? So I'm sure, there are shops like that. Yeah, a lot of people say that, yeah, you go there, you will get it, right? So what does it mean? They're able to better predict the demand and keep the stock ready so that, you'll never come back empty handed, right? And that means that they are, their systems are smart enough to provide that ability, right? So what are the technologies that are helping build such systems? Obviously, these systems are built using a lot of statistical software, and more these days, machine learning algorithms are helping in these systems becoming more smarter. Machines are able to learn patterns and provide better insights. And artificial intelligence, it can think better, it can suggest better, and it can provide you some of the next steps even, right? So hope you are with me so far. We'll have a couple of more challenges. I think we'll cover that, and then at the end, we'll also take some questions. I think the Google form for questions is there in your chat box or even the description of this video. Make sure you click on that and post any of your questions you have, and we will try and address as much as possible depending on the time. Let's get into the next important challenge, right? Which is the fulfillment challenge, right? So we have seen the demand prediction, we have seen order as captured, and now it's a time for the company to deliver, right? Fulfillment is nothing but delivering that order, right? So remember we talked about perfect order. One of the thing is that how do you deliver it perfectly, right? And perfectly doesn't mean that everything is benefit of customer, right? It should not be like a customer should get it on the same day, he should get it in the same quantity, same quality and all. But fulfillment also means the benefit to the company which is fulfilling it or which is delivering it. Can it deliver it in a faster manner, but at the same time with cheapest transportation cost, right? So the goal statement here, as you can see in the screen, how do you make this item available in a fastest possible time with cheapest transportation cost, right? So now let's look at some real life examples again, right? So item was promised to be delivered by a particular date to you, but the actual delivery date is way off, right? We see that many times, correct? It said that it'll arrive by tomorrow, and tomorrow is your birthday, and you're waiting for that item and it doesn't come, right? Of course, the likes of Amazons and Flipkarts and all, they're trying to master this art. But imagine other players, or even imagine situation where before these large players with sophisticated systems, right? It is always a unknown when order will come, right? You want to place an order, but system does not show when it can be delivered. This is another challenge, right? So there is an order button, but when will you click on that? Only you can click on that when you know that you are planning to get it, unless you don't care about when it will come, correct? So you want to place an order, but the system does not show when it can be delivered, right? Or you're ordering a mobile phone, and at the same time mobile cover or maybe a gift wrap or something, and expecting that both will come together. But the first package comes, when you open it, you will see the cover, but mobile comes much later, right? So again, it's not a positive fulfillment experience, right? And your company offering discounted shipping. This is again switching the role here. If I'm a company, I'm offering a discounted shipping. That hey, you order for 200 rupees, I'll give you a shipment free. But my actual shipping cost started becoming a huge burden and hitting on my margins and profit, right? So the problem is, as I said, both for customer as well as for the company which is delivering the goods, right? So let's see what is the wish statement here, right? And what if the fulfillment system is able to factor in items, their size, weight, multiple inventory locations, locations where I store my stock, availability of the items at each location, shipping options from each locations and the costs, and system can take care of all these factors and then suggest the best warehouse to ship it from and the best shipping method, right? Sometimes, shipping it by road, still you'll be able to meet the delivery, right? Or, sometimes, you might have to send it by flight if you really want to keep the promise, right? So all these factors will play in, and IT systems should be able to take all these things and, suggest the best possible fulfillment option to companies. So, these are the steps. Like if you see the image, these are the typical steps happen in a warehouse. So, warehouse receives the order, it processes. There's somebody, picking the item from, various shelves and packing them together, and then, warehouse actually shipping it to the customer, right? So, what do we expect in an effective fulfillment optimization software should be able to do, right? First and foremost, the system should be able to provide a seamless integration, right? Seamless integration means integration between various supply chain systems, right? So there is an order management system, there is a warehouse management system, there is an inventory visible system. Your order fulfillment software should be able to seamlessly interface with all these systems to give you the best possible option, right? Real-time decision making, right? Ability to make real-time decisions, sourcing decisions, where to supply from and how do I supply from, right? And shipment optimization, right? So what does it mean, right? Shipment optimization means sometimes you may have to split an order, sometimes you may have to merge an order, right? So let us say customer has placed two orders and both are going to the same shipping location. Your systems should be able to smartly understand that and make it as one package by combining those items, so that there are two items they're not getting shipped, and it reduces the wastage and packing as well as shipping and other things, right? So that's what we call as shipment optimization, right? Better logistical planning. So system should be able to make decisions based on various logistical constraints, whether it is somewhere some strike is happening, and somewhere number of trucks are not available more, and it should be able to take all those constraints and optimize the fulfillment accordingly, right? And at the end, the end goal is obviously to meet customer SLAs, right? SLA is nothing but service level agreement. So you promise something to customer. Sometimes you may have to ship it through air versus land versus whatever it is, but you should be able to meet customers promised SLA, so that customer will keep coming to you back and back again and again, right? So what are the technologies these optimization systems are utilizing in the background? Obviously, more and more artificial intelligence. This is where the system can take so many parameters like we talked about and able to give you the right output, saying that, hey, do this, right? Big data, there is huge amount of data. Again, it has to process so many items, so many shipping locations, so many transportation mechanisms, and various options and all, right? And obviously, in warehouses, the speeds are improving these days. So manually, people are earlier going to go and pick and pack and doing those things. Now robots are doing that, right? So these are some of the technologies obviously helping in solving some of these supply chain challenges. So we have reached our final challenge that we wanted to talk in this session, right? Traceability and trust, right? Which is more and more important. All the things that we talked about so far are the challenges from ages, and systems are trying to become smarter and smarter, right? And this particular challenge with this e-commerce and with this virtual world becoming more and more important, right? Does the product I bought, is it a legitimate one? Can I trust this? Right? That's a challenge that these systems are supposed to address, right? So let's look at some of the real life examples here, right? So you bought an item, and you bought it. It says organic, and you paid more money for that. But when you really take it, it doesn't look any different than the normal product. And how do you know that it is really organic, whether it is genuine, right? And or you purchased an expensive wine, and somebody told you that it's coming from Italy, but you don't know whether it's really coming from Italy or bottled here, right? And a hospital receives the vaccine doses, and you all know that it requires a cold chain. It has to be maintained at certain temperature, and hospital wants to confirm if the vaccines are kept at the right temperature throughout the supply, right from the manufacturer all the way to place where they're receiving it. Similarly, an automobile manufacturer had to recall the faulty brake pads, right? We see these recalls, quite often, right? So, they realize that, there's some batch of brakes are, faulty or something, and, they want to recall all the cars and replace them for free, right? But only they can do it when they have information on where all that faulty batches got supplied to, which dealers, which cars they went into, and end-to-end traceability is very important here, right? So what is our wish statement here, right? So the trust begins with transparency. We all know that, right? The more transparent you can show the data, the more customer trust you will get it. So ability to customers trust would increase brand's reputation and becomes a strategic advantage in today's competitive market, right? What if a customer can actually look at this and trace that a particular product all the way from manufacturer till his hands. Imagine, how much trust he will have in the brand, right? So that's a wish statement, right? So if you look at the diagram here quickly, right? There are distributors, there are wholesalers, there are retailers, there are raw materials, there are manufacturers. By the time it reaches end users, it's a cycle, right? Raw material all the way to end user, right? And these all systems generate so many events, and if some system is smart enough to capture all those events and make it as chain and show it to you, that's where you can build a trust, right? So an effective, fulfillment effective transparency system, right? Traceability and transparency system software to be able to have these attributes, right? Flexible event data collection, right? So these all systems generate a lot of events. I'm packing it, I'm putting in the truck, I'm unpacking it, and I'm putting in the shelf, and all these are all events, right? So what if it can have ability to accept so many data events without any problem, right? Second is data security, right? And whenever you're talking about trust, you should not allow anybody to manipulate the data, right? Is customizable and scalable, right? System should be able to easily customizable for various industry use cases, right? My store operates in a different model versus next store and all. Your system should not be rigid. It should be able to customizable and at the same time scale to any number of part numbers, any number of events, right? IoT integration, right? Internet of Things. These are the small devices that can transmit enormous amounts of data and gives you valuable information. So if you look at on the left side, we talked about vaccine situation here. And what if each vaccine batch you can attach an IoT device, and it keeps sending the thermometer, the reading, temperature reading to a system where nobody can tamper it. And when the hospital is receives, it can check all those events right from manufacturer to here, including the temperature. Imagine the trust level, right? Document management. So what documents we are talking about here? Document management is nothing but ability to store multiple regulatory documents at various stages. For example, we talked about organic products, right? So at the time of manufacturer or the farmer putting the items on the truck, what if some government agency is checking that and then uploading that authenticity document right there and there into the same system. And when the end user receives it, they'll be able to check that system, and that it is not tampered, right? So the systems are should be able to capable of dealing with all these parameters and attributes, right? So what are the technologies that are helping such building such transparency here, right? Blockchain. I'm sure we all heard about blockchain systems and all. This is where they come. Their main use case of blockchain systems are here, right? IoT, Internet of Things, we talked about. APIs, to receive such events and store those events in an application program interface way. UI technologies, obviously, gathering all these events is one, and showing them in a proper manner is another one, right? And mobile apps, right? So if you look at the last statement here, I mentioned here, very soon, just by scanning a QR code on the label, a customer will be able to trace the product all the way from source, raw material to finished goods with authenticity certificates at various stages, right? So what else is happening in the supply chain, right? So what else is the technology happening in the supply chain, right? So so when we finish the talking about some of the challenges, there are certain things like supply chain analytics, which are coming into play, which are giving, looking at massive amounts of data and able to make sense of all this data, right? So there are different types of analytics we are talking about here. One is descriptive. So descriptive analysis is nothing but, what happened, right? If it can provide information by going through so much data and say that, oh, this is what has happened, right? It could be inventory trend, it could be return on, investment of capital. Those are the things if it can give, we call them as descriptive analytics, right? Diagnostic analytics, right? These are the analytics which can give why, questions. It can answer questions like, why did it happen, right? So let us say if there is a shipment delay, if the analytics can tell you that, oh, this is the reason why it is happening, right? That's a diagnostic, right? So next level of analytics is predictive analytics, right? This is something like what will happen in future, right? So example, there is a pandemic happening. What happens to the raw material and other things, and if your analytics can tell you that, that's called predictive analytics, right? The other type of analytics here is prescriptive analytics, right? This means system should be able to suggest you what I should do, right? So timing of product launch, this can be an example. Best shipment strategy we talked about, right? These analytics can give you that information of what I should do. This can help me a great deal, right? And where does all the supply chain analytics will become visible and help in decision makings? This is where we call about concepts called supply chain control towers. This is the latest evolution of taking all these analytics and making sense of that in a personalized dashboard view. And it can show me some my business metrics, my KPIs, key process indicators and all, across my supply chain, right? And how does these control towers add value? They provide end-to-end visibility. They help in collaborative, information sharing between various teams, and they can help reduce manual process and manual analysis and all that, and get real-time actionable insights where you can really take an action if something happens in supply chain. And they can also better predict disruptions, improve resiliency, and also manage exceptions to any unplanned events, right? So, what does it all this mean, right? So it all means that, so future is all about self-correcting, which means autonomous decision-making. System should be able to correct when a supply chain disruption happens, and resilient. It can bounce back even if something happens, and quickest possible times, right? That's what is future supply chain, and all these technologies are helping there, right? Let's quickly look at, what are the types of that we have, right? I'm talking only in the IT field here. There are multiple roles in the supply chain field itself, where like inventory planners and demand planners and all that, right? But in the IT side, if you come, there are application developers who should be able to develop and install or configure and maintain these supply chain systems, right? Like different systems we call about order capture, where order is actually captured from the customer, order fulfillment, and websites and mobile apps and all that, right? And then there are these ERP consultants. ERP systems are nothing but enterprise resource planning systems. These are the systems which can help in any manufacturing or supply chain process end to end. And the things like if you have heard like SAP, BAN, PeopleSoft, Oracle, these all have ERP softwares. So ERP consultants are in full demand. EDI analysts, these are the electronic data interchange experts, which can understand how a business documents can be exchanged, how to convert those documents into a standard format so that it can be exchanged between two systems in a much faster and error-free manner. AI experts, artificial intelligence, obviously helps build models and algorithms and integrate them with supply chain IT system to solve some specific supply chain problems, right? Blockchain developers, we saw use cases there, which helps set up blockchain networks for a supply chain community. Community is nothing but all the way from supplier to end customer, right? And helps in onboarding various participating organizations at various stages, and helps build smart contracts to execute based on predefined agreed terms, right? Earlier we talked about a threshold. When a quantity reaches a particular threshold, can it make an order automatically, right? To supply for more goods, right? So this all can happen through blockchain. On the client success side, as more and more systems are converting into software as a service, there is new age roles that are coming in, which are becoming more popular. which are client success managers, right? Who advise customers on best practices of implementing a particular software, who provides customers with, who provides organizations with some statistics and provides guidance on how to get best value out of all these softwares, right? So we call them as client success managers, right? So I think we reached the last 10 minutes of this session. So let's quickly pause for a minute and look at, if we have received any questions, right?
Questions here. Okay.
Here, and that session is good. Agriculture engineering student, how can I get this get into the field of supply chain equipped with latest technologies such as blockchain, data analytics, etc. Also, can you share some aspects of AI, data science that can, in agricultural, scenarios? Obviously, right? So, agriculture, the more and more blockchain is getting used in agriculture. The concept called farm to fork, right? Farm to fork, right? From the farm all the way to your fork and the data table, dining table, you have multiple technologies that are helping here, right? From IoT technologies, where you can learn, technologies right from giving the information about soil moisture, soil quality, all the way, temperature of the goods, whether something is maintained at a cold chain and received at the customer end, and it gets delivered. So the combination of IoT, blockchain, and all these technologies that we talked about are helping agricultural suppliers to become better at it, and then obviously build more trust, right? Similarly, we talked about the organic farming and all. These technologies will help preserve that authenticity and makes it as a competitive advantage, right? So yeah, there are questions also, like there's a question on maybe quantum computing. This is the latest buzzword. Can it help in supply chain? Yes, obviously, right? So quantum computers are nothing but computers that can do processing at 100 million times faster than the traditional computers today, right? So imagine a quantum computer that can predict and analyze and look at all these stock out scenarios and all, right? All the things that we talked about, demand prediction, or loyalty, customer loyalty, and everything, right? If if quantum computers can be programmed in such a way that it can give customers and even the companies more insights in a much real-time manner, obviously that can help, right? Another area where such things will help companies is when they start showing relevant products, right? So imagine you log into Amazon and try to buy a mobile phone. It starts showing all the relevant products in the below, right? There are mobile covers and screen guards and other things. How does all this happen? There are systems running in the background understanding relationship between your past orders, or the current page that you are looking at it, and how fast it can suggest something to you which is a value add. You can make more money on that, right? Any other questions that we have? Let me quick. Okay, we do not have any questions. I really hope you're able to get some insights into some of the supply chain challenges that we are seeing, and also how various IT systems using different technologies are really helping make sure that these supply chain systems are becoming more smarter and more adaptable, more accurate, and at the end achieving the goal of a perfect order always. The more percentage of perfect orders, the more the brains behind these systems working together to make it possible, right? So thank you again for your time, and have a good evening or good rest of the day, all of you.